to model the convergent divergent nozzle. So you can see I'm saying it is a convergent divergent nozzle because at the front part it have a convergent portion. So this is the inlet. From here to here it is converging, and after that if you see from here to in the forward direction it is in the divergent portion. That means area is increasing from here to here, whereas if we see the first part from here to here area is decreasing. So for that reason I will be calling the front part as a convergent and the later part I will be calling as a divergent. In between we have another cross section or another part where we have a very small area compared to convergent and divergent part. This we called as a throat. Okay, now uh, when when you see at the inlet we will be having very low velocity and will be having very high pressure. This very low velocity and high pressure, when these will pass through the convergent divergent nozzle and it reaches a very high velocity and very low pressure. Okay, after passing through this convergent divergent nozzle, the velocity is increases to very high and pressure is decreases to very low. So this scenario is used to test the ramjet engine. So if you see, we'll be placing a ramjet engine at the exit of the convergent divergent nozzle, such that the whatever real scenario will be achieved in the air, that can we can create in the wind tunnel with the help of these type of experimentation or setup. So the same real scenario we can create and we can see the fluid flow behavior over the ramjet engine. Now, now to model the convergent divergent nozzle, first we will try to open Workbench. In Workbench we have a different analysis systems are there. From there I will be considering fluid flow fluent. In fluid flow fluent we have a geometry, mesh, setup, solution and a result. In that I will right click on geometry, then go to new design modeler geometry. I will be selecting the new design modeler geometry. Okay, this is our new design modeler geometry. From here you can see we have a tree outline. uh, we have a xy plane, zx plane and ZY planes will be there. So we are not created any surfaces or body. For that reason it is showing 0 parts and 0 bodies. Now what I'll try to do, I will go to units and I will select millimeters. So I will try to design my geometry, that is convergent divergent nozzle in millimeters. Then after selecting millimeters, we can see scale it here. It is showing 0, 22.5, 45.0, 67.5, 90.00. This scale is in mm. Then you can see here it is our isometric view. I want to convert it into orthographic view. At the top I have a look at face option. I will try to select the look at face option. When I click here, so you can see this is my orthographic view and it is my y z plane. So this is my y z plane. If I select xy plane, you can see when I select xy plane, then I click on look at face. Now this is my xy plane. If I select zx plane, again it was shifted. It is zx plane, but it is showing me x and y plane. And when I click at look at face, now I am in zx plane. What I will try to do, I will select xy plane, then I will click at look at face. So this is my xy plane. I will try to zoom such that because I will be using very small dimension, so for my convenient I will be taking some highest range is 7 mm. You can see my highest range is 7 mm. For my convenient I will be choosing. Then what I will try to do, I will go to sketching here. Then in sketching I have a different options are available: draw, modify, dimensions. What I will try to do, I will go down at the draw toolbar. I will select construction point. So I will construct one point above my x-axis. You can see the red color shows me x-axis, the green color shows me y-axis. Then what I will try to do, I will locate a point above my x-axis onto y-axis. Similarly, I will locate one point below x-axis onto my y-axis. So these are the 2 points. Now what I will try to do, I will go to modify, and there I have, okay, no, I need to go to constraint. I have a symmetry option. I will go to symmetry. First, what is asking, you can see at the bottom, select a line for axis of symmetry. So it is asking me the axis line for our symmetry. So I will select my axis line. Now it is asking select first point. So I will be selecting my first point, which is above point. Now it is asking select second point. I will be selecting the second point. Now you can see these 2 points are symmetric about x-axis. Then I will go to dimension. Then I will select vertical. Now it is asking the dimension for my point. So I will select my x-axis. Then I will select my above point. Now I will drag my dimension at the left direction. Now you can see the V1 dimension, whatever I just selected, it is showing 2.2154, but I need to view the vertical height is 6.3 according to my dimension of convergent divergent nozzle. So this is my 6.3 mm. So you can see when I zoom out, I given only the 6.3 for the above point. Due to that, what these 2 points are symmetric about my x-axis, the other point also adjusted according to this dimension. Now after constructing our first point, then go with another point. I will be going to draw. There I have a construction points at the bottom. I will select construction point. Again I will locate one point above, one point below. Again what I try to do, I will go to constraint, symmetry. Now I will select x-axis. Then I will select above point and below point. Now these 2 points are symmetric about x-axis. Now I try to give dimension. I will select horizontal. Now I will select my vertical axis. Then I will select my second point. I will try to give dimension between these 2 points is 1 mm. Okay, you can see the point to the bottom point was adjusted according to top point. Again I will go to vertical. Now I will select horizontal axis and I will select above point. I will be giving vertical dimension. V1 is the first vertical point dimension and V3 is our second vertical point dimension. I will be giving again 6.3. You can see I constructed 2 points above, 2 points below parallelly, which are symmetric about my x-axis. Now after constructing these 2 points, again I will go to again draw. At the bottom I will have construction points. Once again I will be locating my third points, top and bottom. Then I will go to constraint. I have a symmetry. Again I will select x-axis. Then I will select top point and bottom point. Again these two are symmetric about my x-axis. Then I will go to dimension. I will select horizontal. Now I will select y-axis. Then I will select the third point. I will drag my dimension above. You can see the second point is at a distance of 1 mm from the y-axis. I will be increasing in steps of 1. So I will be giving 2 mm for my third point. Again I will go to vertical dimension. I will select horizontal axis. Then I will select the third point. I will drag my dimension at here. You can see it is showing me V5. Okay, I will try to go to V5. I will be giving my value is 6.2. So I constructed 3 points at here. Okay, in similar fashion, we can see we constructed all the points. You can clearly see here we constructed all the points from the inlet. So this is the inlet portion, from the inlet to throat, and from throat to we have exit section. So this is so we constructed all the points for our convergent divergent nozzle. So our next step, we will try to create a we will try to join these all points with a spline. So uh, in the draw toolbar itself we have a spline here. I will take spline and you can clearly visualize how we are going to join all these points. We try to carefully need to join these points. I will select first point. You can see when I'm moving my cursor, it need to locate P, not the C. You can use pan. You can clearly join. So you need to see that it should select only point. Okay, it need to select only P, not the C. So when I move my cursor, it is showing me P. I will select that point. Then I will select second point. Then I will select third point, fourth point, next, next, next. You can see you need to join these points very carefully. Okay, otherwise you will be unable to get smooth profile. Okay, you can join these points and you can use a pan option to move to your convenient points. Okay, you can use pan option very conveniently. It won't distract your. Okay, okay, we need to join them carefully. Okay, I will be joining these points very carefully. Okay, you can see so I joined most of the points. I will be using a pan option. You may get confused at here. I will be using pan option to move my points. Now you can see. So when I want to select next points, so I am unable to select this one. So what I'm trying to do, because it is not displaying me to select P point. For that reason, what I'm going to do, again I will be deselecting point. Again I will be selecting point here. Here what happened? A new point was selected it here. So what I will try to do, I will do a undo option here. You can see I will be doing undo, so I can continue by selecting a next points. You can clearly see how I will be selecting the next 2 points. Only we need to select the points. Again, I will be doing similar process with the help of pan. Still I am unable to select this point. I will be unselecting point selection. A line was drawn. I will go with a undo. Okay, now I can select my, okay, I am unable to select. Again I will select point. Okay, I will do again undo because my line was already selected somewhere else. I will do undo. Now you can see point was highlighting now. Okay, lot of people are getting confused how to select these points. Okay, you can see this is my last point. After that I will right click here and I will select open end. Okay, we need to select after right click at the end point and select open end. This will create you a smooth profile for our upper points. You can clearly see points are joined with the help of spline. Okay, these points are joined with a spline, you can clearly see. Then similar way we try to join the bottom points with the spline. Okay, we similar to above, we already joined bottom points with the spline. Okay, you can clearly see the top points and bottom points are joined with the spline. Okay, these points are joined. Now what is the next step? Next step we try to join these upper and bottom end points with a straight line. You can see this is my top point and it is my bottom point. These 2 points are must and should join with a line because I will be closing my profile. Again I will go to line. I will select top point. It is selecting C because I didn't uncheck my edge selection. Now I will go to now I can see point at here at the top, point at the bottom. Now I was closed this convergent divergent nozzle at the inlet and at the exit. That what I will try to do after that. I will try to create a surface. When I click on generate, now I will try to create a surface for this 2D sketch. At the concept I will have a surfaces from the sketches. Then I will select this one and it is asking me to select sketch. I will select sketch 1. Now the sketch 1 was highlighted. Then click on apply. Okay, then it is asking me generate symbol, then click on generate. You can see my surface was generated with the uh, represented points and profile. And now you can see in part body it is showing one part one body. When I click on surface body, it is default, it is showing solid, a fluid solid. You can see it is a solid, but I need to do a convergent divergent fluid flow analysis. For that reason I need to select as a fluid. Default it is a solid, I need to change it to fluid. Now you can see the surface area of the convergent divergent nozzling is showing it here. Here it is total 1 faces is there, total 4 edges it was created, total 4 vertices it was created. So this is my geometry which was in future I try to do simulation on the convergent divergent nozzle. Now I will try to close this design modeler geometry. Okay, so my geometry was given a tick mark. So that means geometry was finished. The next part I will try to do meshing. After meshing I will try to go to setup. In setup I will give boundary condition and then I try to solve this one, and later I will see the results. Okay, these things we will see in upcoming video lecture.